Projective Geometry, Volume 1, by Oswald Veblen and John Wesley Young.
Chapter 5, Conic Sections. Section 45, Degenerate Conics. For a variety of reasons, it is desirable to regard two coplanar lines or one line, thought of as two coincident lines, as degenerate cases of a point conic. The duality to regard two points, or one point, thought of as two coincident points, as degenerate cases of a line conic. This conception makes it possible to leave out the restriction as to the plane of section in Theorem 1. For the section of a cone of lines by a plane through the vertex of the cone consists evidently of two distinct or coincident lines, i.e. of a degenerate point conic, and the section of a cone of planes by a plane through the vertex of the cone is the figure formed by some or all of the lines of a flat pencil, i.e. a degenerate line conic. Exercise. Dualize all possible ways the degenerate and non-degenerate cases of Theorem 1. Historically, the first definition of a conic section was given by the ancient Greek geometries, e.g. Menaechmus, around 350 BC, who defined them as the plane section of a right circular cone. In a later chapter, we will show that in the geometry of reals, any non-degenerate point conic is projectively equivalent to a circle, and thus that, for the ordinary geometry, the modern projective definitions given in section 41 is equivalent to the old definition. We are here using one of the modern definitions because it can be applied before developing the Euclidean metric geometry. Degenerate conics would be included in our definition, page 109, if we had not imposed the restriction on the generating projective pencils that they be non-perspective. For the locus of the points of an intersection of pairs of homologous lines in the two perspective flat pencils in the same plane consist of the axis of perspectivity and the line joining the centers of pencils. It will be seen as we progress that many theorems regarding non-degenerate conics apply also when the conics are degenerate. For example, Pascal's theorem, Theorem 3, becomes, for the case of a degenerate conic consisting of two distinct lines, the theorem of Pappus, already proved as Theorem 21 of Chapter 4, chiefly, in particular, the corollary. The polar of a point, with regard to a degenerate conic consisting of two lines, is the harmonics conjugate of the point with respect to the two lines. Chiefly the definition, page 84, exercise 7. Hence, the polar system of a degenerate conic of two lines and dually of two points determines an involution at a point or on a line. Exercises. 1. State Briançon's theorem, Theorem 3 prime, for the case of a degenerate line conic consisting of 2 points. 2. Examine all the theorems of the preceding sections with reference to their behavior when the conic in question becomes degenerate.
Projective Geometry, Volume 1. This book was written by Oswald Veblen and John Wesley Young. It was published by Blaisdell Publishing Company, London, 1910, and is now in the public domain. It is read by Jim Renholt, with programming and illustration by Jim Renholt, 2019. Thank you for listening.